Okay, so what we're given here is we're given a trigonometric equation, and this specific trigonometric equation states that 1 minus cos squared of theta over 1 minus cos of theta minus 1 equals 1/2. And what we're trying to do is we're trying to solve for all of theta's values. We're trying to find all possible values of theta, and essentially what theta is it's an angle measure that would satisfy this equation right over here. And so that's exactly what we're going to do in this video. We're going to solve for all possible values of theta. And so by doing this, so essentially what we're going to do is we're going to first factor out the numerator of the left side of this equation. So 1 minus cos of theta multiplied by 1 plus cos of theta. And at the same time, we're going to leave the denominator as the same. 1 minus cos of theta. And so now what you see that we've done is that we've created a multiplied we've created a set of two binomials, the numerator, and one binomial in the denominator. And essentially what we can do is we can just cancel out one of the factors of the numerator and the entire factor of the denominator, and we are left with 1 plus cosine of theta minus 1. Remember, we have also kept this in the equation is equal to 1/2. And so now what we can do is we can simplify the left side of this equation by canceling out these ones. We'll go for the cosine of theta is equal to 1/2. And so it might seem like we are done with this problem, but we are not. We still have a cosine of theta is equal to 1/2, and we've still not found theta itself. And so right now what we're going to do is we are going to find on the unit circle where cosine or the x component of the angle measured theta is equal to 1/2. And so if I could just draw a unit circle right up here, this is going to be a very bad drawing, but that should not be okay. We can see that cosine of theta, or the x value of theta, is going to be positive only in this region, only the first and the fourth quadrant. And so the radian in which cosine of theta is going to be equal to 1/2 is going to be at pi over 3 and this other component, which is going to be at 5 pi over 3. And so now what we have found is we have found both solutions that would satisfy this equation. But what the question is, what we're really trying to find for is we're trying to find for all possible values of theta, all possible values, not just pi over 3, not just 5 pi over 3, but all possible ones. And so how are we going to do this is we are going to write a set of two equations, specifically one for each value that we've derived, and we're going to write an equation for each that would that would describe the possible values of theta for for each of those derived radians. So not pi. Theta is equal to pi over 3 plus 2 pi n. And essentially what 2 pi n means that every single time you revolve around the unit circle, every single time you revolve around it 360 degrees, you're going to achieve all the possible values of pi over 3, all the possible values of theta for that specific derived radian, in which cos of theta is equal to 1/2. Again, referring to this equation right over here. And also another equation for theta is going to be 5 pi over 3 plus 2 pi n. And so again, referring to that 2 pi n, it's going to be 2 pi n because every single time you revolve around the unit circle 360 degrees, you're going to get back to you're essentially going to include all the possible values of theta for that specific radian, which is 5 pi divided by 3. And another thing that you can also do is you can also so you can subtract 5 pi over 3 from pi over 3, and you can also get 2 pi n. And so now what we've done is we found the two different equations that is able to include all the possible values of theta for this specific trigonometric equation right over here. Thanks for watching. I hope you learned on how to solve trigonometric equations, specifically with factoring, as well as simplification, identifying which radian on the unit circle is would serve as a reference point in finding the other values of theta for that radian or radians, and then also using the 2 pi to include all the values of theta. So yeah, please like and subscribe, and thanks.